Hello guys, how are you? I hope you're fine and you might be doing pretty good. Welcome to my channel with GR of Talents. So, in today's video, we are gonna look at the chapter Force and Laws of Motion. By the name of the chapter only, you might be guessing that it's of chapter 9 and class 9 to 9s if you observe it here of CBSE NCERT. So, in the previous video, we have already seen the basic concepts of this chapter, that is, different types of unbalanced and balanced forces. So, if you hadn't watched that video, you might not be understanding this part of it. So, watch this video right now if you hadn't watched it. So you might be wondering where to watch it. The link is in the description. Watch it right now. So in this video, we are going to look at the Newton's laws of motion. So for the ones who don't know, Isaac Newton. Sir Isaac Newton, PRS, was an English mathematician, physicist, astronomer, theologian, and author who is widely recognized as one of the most influential scientists of all time and as a key figure in the scientific revolution. So by the age of 5 years only, you might have heard the name of Isaac Newton minimum 5 times in your life. So now you must be approximately 13 to 14 years, so you might be hearing it thousands times. So most of you might be knowing about Isaac Newton, but it's just a short introduction. So first, there are 3 laws of motion. First, let's look into the first law of motion. First thing first. So, by observing the motion of objects on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts on them. So he also observed that when a marble rolls down an inclined plane, its velocity increases with time. So observe these pictures here, A, B, C. So its velocity decreases when it climbs up as shown in the figure B. C shows a marble resting on an ideal frictionless plane inclined on both sides. So now another famous scientist, Galileo, argued that when the marble is released and go up on the opposite side of the same height from which it was released. So if the inclinations of the planes on both sides are equal, then marble will climb the same distance that it covered while rolling down. So if the angle of inclination of the right side plane were gradually decreased, so then the marble would travel further distances till it reaches the original height. So if the right side plane were ultimately made horizontal, that is, the slope is reduced to 0, the marble would continue to travel forever, trying to reach the same height that it was released from. So now the unbalanced forces on the marble in this case are 0. So it does suggest that an unbalanced external force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. If you imagine them in practical situations, it is very difficult to achieve a zero unbalanced force. This is because of the presence of the frictional force acting opposite to the direction of motion. So, actually I want to tell you something out of the book. So I won't tell you everything about this thing, but I'll give you some sort of information so that your brain gets active and you start thinking and surfing stuff. So an object was released from Earth actually. So in the space there is no friction. So according to the first law of motion, it should prove that some object, if left in place, any frictionless surface, it would be going on moving. So an object was released from Earth, so it has now almost crossed Mercury. It was released almost 8 years before. So I want you to find out what is the name of that thing and let me know in the comment section below. So let's come back to this marble thingy. So thus in practice, the marble stops after frictional force. Due to frictional force, it stops after some distance. The effect of this frictional force may be minimized by using a smooth surface and a smooth plane, and even providing a lubricant on top of the planes. So you might be knowing what a lubricant is. So Sir Isaac Newton further studied these Galileo's ideas on force and motion and presented three fundamental laws that govern the motion of objects. So these are nothing but Newton's laws of motion. Actually, if we have to say it much precisely, it's not only Newton, but Galileo gave most of the information of findings that were left behind by Galileo were used by Newton, and he studied them further. So Galileo can also be given equal importance. So these three laws are known as Newton's laws of motion. So we are talking about the first law of motion. So let's see how can we state the first law of motion. An object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. So this is basically the first law of motion. This is a straight definition. If you get this question in exam, you can directly write this. So just learn it and keep it in your mind. So then in other words, all objects resist a change in their state of motion. In a qualitative way, the tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is nothing but inertia. So that is why the first law of motion is also known as the law of inertia. So if you see here, this guy is thinking, will the ball stop? By these findings, you should be able to answer this question. Your answer should be something like this. The ball will keep on moving according to first law of motion, or what is the other name? It's the law of inertia. So it should be moving unless and until an external force is acted on it. It is mostly not possible on Earth because Earth contains friction everywhere. So if you are thinking that friction is only present on the surface, then you are wrong. For the ones who know it, you are superb. But for the ones who don't know it, there is also friction in air, which is nothing but fluid friction. So fluid friction consists of both the friction in liquids as well as in the gases. So in this video, we have already seen about Isaac Newton, Galileo, and the laws made by Newton. And we have also known how to state Newton's law of motion, the first law of motion. So let's learn some examples and as well as some more concepts related to the first law of motion in the next video of Jar of Talents. And thank you very much for watching this video. Have a very great day.